Akthab, Bifaz. Today in this video we are going to discuss how bucket sorting algorithm works. So let's get started. So what are we going to cover in this video is what is bucket sort, how bucket sort works, and the bucket sort algorithm and complexity of the algorithm. We are going to have a brief look at all of these topics today in this video. So what is bucket sort? Bucket sort is a non-comparison based sorting algorithm that assumes it's possible to create an array of buckets and distribute the items to be sorted into those buckets. Therefore, as a prerequisite for even using bucket sort in the first place, we have to find some way of obtaining the index for each and every element in the array. So bucket sort is mostly used when input is uniformly distributed over a range and if there are floating point values. So now let's see how bucket sort algorithm works. So if we take this input array, we'll see how it is sorted using bucket sort algorithm. So if we take the first element, it's 0.03, and if we multiply it by number 10, we get 0.3. If we round it off, we get 0. So the first element goes to the bucket number 0. So and if we loop through the array, we get 0.16. And if we 0.16, and if we multiply it by number 10, we get 1.6, and if we round it off, we get 1, which means the bucket number 1 gets the element number 2 in the array, which is 0.16. So if we loop through the array again, we get 0.15, which we multiply by number 10, and we get 1.5, and if we round it off, we get 1. So the bucket number 1 again gets the third element of the input array. So if we loop through the array input array again, we get 0.27. If we multiply it by number 10, we get 2.7. So the bucket number 2 gets the fourth element of the input array. And again, if we loop through the array, we get 0.35. And if we multiply it by number 10, we get 3.5, which means, and if we round it off, we get number 3. So which means bucket number 3 gets 0.35. And finally, if we go to the last element of the input array, we get 0.18, which we multiply by number 10, and we get 1.8. So if we round it off, we get 1. So the bucket number 1 gets 0.18. So that is how bucket sort works. So this is the sorted array we got. So each and every bucket are sorted independently using a sort algorithm such as insertion sort or any other method of sorts. So let's see the bucket sort algorithm. So this is the main algorithm of the bucket sort. So we should create n number of buckets, the whole range of values. So for all the buckets, initialize each bucket with 0 values. So for all the buckets, put the elements into buckets matching the range. So for all the buckets, sort the elements in each bucket, and finally gather elements from each bucket, and we end bucket sort. So this is like a pseudocode for the bucket sort algorithm. So if we go to the complexity of the bucket sort algorithm, best case complexity, worst case complexity, average case complexity. So first of all, what is even complexity of the algorithm? This means the complexity is a measure which evaluates the order of the count operation performed by a given or algorithm as a function of the size of the input data. So put this simpler, complexity is a rough approximation of number of steps necessary to execute an algorithm. So if we take the worst case complexity of the bucket sort algorithm, so when there are elements of close range in the array, they are likely to be placed in the same bucket. So this may result in some buckets having more number of elements than the others. It makes the complexity depend on the sort and the bucket sorting algorithm itself. So this is the worst case complexity of the bucket sort algorithm. So if it takes the best case complexity of the bucket sort algorithm, it occurs when the elements are uniformly distributed in the buckets with a nearly equal number of elements in each and every bucket. The complexity becomes even better if the elements inside the buckets are already sorted. So if you take the average complexity of the bucket sorting algorithm, it occurs when the elements are distributed randomly in the array, even if the elements are distributed uniquely. So the bucket runs in linear time. So these are the best case complexity, worst case complexity, and the average case complexity of the bucket sort algorithm. So this is the Java code of the bucket sort algorithm, and this is the input array or the array we are going to sort today using bucket algorithm. Here we can see we have 7 elements in this array. So we create empty buckets here. So the empty buckets are created according to the number of elements in the input array we are going to sort. So here we create 7 buckets, and then we add element into those buckets according to the bucket index. So as you can see here, we got the bucket index using the elements of the input array, multiplying that by the number of elements in the input array, and then we add those to the particular buckets, and then we sort those elements in each and every bucket using collection sort. Here I have used collection sort, or else you can use any sort of algorithm like insertion sort or any other method. And then we get the sorted array using these 2 for loops, and finally we print the sorted array in this for loop. So that is how we do the bucket sort using Java program. So as a summary, we can say that the process of bucket sort can be understood as a scatter-gather approach. The elements in the array are first scattered into buckets, then the elements are sorted, finally the elements are gathered. So that's all for today in this video, and I hope you all learned something from this bucket sort algorithm. So until next time, goodbye.